All right, today we're going to work on expressions involving absolute value. Um, I think we've talked a little bit about absolute value so far, but we're going to go into a little bit more detail today. All right, this is really using a definition of absolute value, understanding what that definition means, and then applying it to some really basic context. Um, so, first of all, let's talk about absolute value. The idea of absolute value is it is the distance a number is from zero on the number line. And the key here is distance is always positive, which you could also call non-negative in this case. Okay. So what that means is if you start at zero and walk to the right, or you start at zero and walk to the left, you're still walking a distance. It doesn't matter if you go left or right, you're still covering ground, so to speak. So distance is always going to be positive. And that's what absolute value really does. Let's look at some examples here. All right. So here are several examples for us to go through. All right. And so the first one is, this is a question: what is the absolute value of -5? So basically, we're saying, all right, here's zero. How far from zero is -5? Well, if you were to start at zero and go to -5, you go one, two, three, four, 5 units. So the distance from -5 to zero, or zero to -5, it's the same thing. That distance is 5 units. Okay. How far from, or excuse me, the next one says, what's the absolute value of five? So how far from zero is five? And again, whether you go from zero to five or count from five to zero, you're counting 5 units. So there's actually two answers for, you know, um, how, or excuse me, what's the absolute value, or excuse me, what numbers have an absolute value of five? There's two answers: -5 and five are both 5 units from zero. All right, next one. What's the absolute value of -3.25? Well, 3.25 is 3.25 units from zero. If I count from zero to 3.25, or 3.25 to zero, doesn't matter if I go right to left or left to right. Okay, the answer is 3.25. All right, how far from zero is -2/3? Well, -2/3 on a number line would be located a little bit more than halfway from zero to -1. Okay, but again, how far is -2/3 from zero? It's 2/3 units from zero. -7 and 4/5. Well, on a number line, it's about right here. Okay, -7 and another 4/5 of the way to -8 is about right in here. How far from -7 and 4/5 is zero? 7 and 4/5 units. So you can see all the answers are positive. And the reason I went up here and said non-negative is because of this last example. Okay, what's the absolute value of zero? Well, zero is 0 units from zero. All right. And zero is not considered to be a positive or a negative number. Okay. So that's the only reason we don't say all the answers are always positive, is because you could get zero, which is technically not a positive number. In every other case, the answer is positive to absolute value. All right. So you're going to be asked questions like about this concept tonight, which is that, remember that the absolute value is always the distance a number is from zero. Okay. So first kind of question: find all numbers whose absolute value is five. If there's more than one, separate with commas. If there's no such numbers, click none. All right. So we need to find all numbers that have a distance from zero that is five. So if you kind of look at it on a diagram, if I go from zero to the right 5 units, I'm at +5. If I go from zero to the left 5 units, I'm at -5. So both five and -5 are 5 units from zero. Okay. Kind of talked about it on the last slide. Find all numbers whose absolute value is -3. If there's more than one number, separate with commas. If there's no such number, click none. Okay, hopefully a little red flag went off. I already told you that distance is always positive. So is it possible to have an absolute value, the distance from zero, to be -3? The answer is no. Absolute value is never a negative number. Okay, distance is always non-negative or positive. So there are no such numbers along the number line that are a negative distance from zero. Okay, I know you can go to the left or go to the right. Going to the left doesn't make it negative. You go to a negative number, but it's not a negative distance. So be careful when it says the absolute value equals a negative number, because that doesn't happen. Okay, now we'll do some simple expressions tonight also. And the idea here is, uh, when we do expressions that involve absolute value, you have to work inside the absolute value symbol. to work this down to a number, a single number, and then take the absolute value of the number, and then you can start applying it to other operations. All right. So this absolute value is like a grouping symbol in that you got to do all the work in here first. Now, I will say this: you cannot distribute through the absolute value. So it's not resembling a grouping symbol in that fashion. It's really just a parentheses that I have to do all the work in here first, and then apply absolute value, and then do the rest of the problem. So in our first case here, it just says we got to take the absolute value of -2 and add 7. Well, we're ready to go. Absolute value of -2, we all know is 2. 2 plus 7 is 9. Done. Okay. Look, another example. Now, did this on purpose to show you the difference here. Now the absolute value is around both the -2 plus 7, or the whole statement -2 plus 7. Okay. So now we have to put these two together before we take the absolute value of it. I want to take the absolute value of the answer. So -2 plus 7 is +5. The absolute value of +5 is 5. So, a lot of the same components here, but because of the way it was written, you get two different answers. Okay. So you got to work that absolute value inside the absolute value symbol first. We got to work this process first, and then apply the absolute value when you got it worked down to a number. Okay, a little bit more complex version, not a whole lot more, but we got to work each one of these absolute values separately. Okay, so in my first absolute value, I have to do 6 minus 15. All right, so that's going to have to be rewritten as an absolute value of the answer to that. The one over here, though, is just the absolute value of -15. So I can do all that. So what we're going to get here is the absolute value of 6 minus 15. That's going to become the absolute value of -9. I rewrite it and put the answer to 6 minus 15 in there. I haven't used the absolute value yet. I've just worked inside. Over here, we used the absolute value to say that the distance -15 is from 0 is 15. Now notice the minus sign just came down. Okay. Now I have to do this absolute value. So the absolute value of -9 is 9. And now 9 minus 15 is -6. Now, if you're thinking, you told me that absolute value is always positive. Well, it is always positive. The absolute value of -9 was +9. The absolute value of -15 was +15. But the operations brought us down to this negative answer in the end. Okay. So don't get confused by that. One more example here. Again, I have two different absolute values. I got to work them separate. The first one is just a single number inside there, so I can execute that one right away. The absolute value of -10 is 10. The absolute value symbol is now gone. We've answered that question. How far from 0 is -10 is 10. Here now, though, I got to work. I got an operation to perform inside this absolute value, and I got to do that before I take any absolute value of it. So -2 minus 11 is -2 plus -11. That's -13. And I leave absolute value around it because I haven't done it yet. Now I'm going to answer this question. How far from 0 is -13? 13 units. So now I got 10 minus 13. 10 minus 13 is -3. All right. So we be sure that we do the work inside absolute value and then apply the absolute value concept to this number and then finish our problem. All right, so that's really all we're going to work on tonight is those kind of questions. So, make sure you're writing notes down, because remember, you can use the notes on the quick checks that you're going to be doing. So be sure you're doing that. Stay organized. Keep a nice notebook of everything that we're doing so you can use it. And I will let you get going.